carried through that pendulum. So the speed that the top part is actually moving is definitely going to affect, you know, that pendulum. So when you start moving to the right, which is good, like that's great. It starts to move and your pendulum is catching up. So you probably won't move as much as the top one because it's heavy. When it gets here and the top one slows down, see how the flying saucer, whatever it is, slows down right there. When it slows down, that thing is carrying enough energy and weight with it that it will start swinging earlier. Like right now, yours is basically getting stuck. If you watch this, it feels like, see how it gets stuck? It shouldn't get stuck as much. When the saucer goes, it's moving forward and it slows down right here. When it starts to slow down, it starts to slow down around this frame right here. This already right here, that pendulum, right? See when it's completely almost stopped right there, that pendulum will start to swing forward. It's starting to catch up. It probably won't swing really fast, but it'll start swinging because this thing has weight. You started by giving it weight. The whole first part, that's weight. It has weight right there. See how long it takes to actually start swinging? It's nice. But here it gets really light because it's not swinging. So it needs to swing. Make it swing earlier. So by this frame, it should already be there. And maybe even start to swing back forward. And then, as it goes this way, now it will start swinging this way. See that? Mm-hmm. You don't want your spaceship there to be moving to the right, and this is curling forward, right? If it's going to move, especially that fast to the right, that thing will be dragged behind. You know, always remember that when you have a force that's going in one direction, if there are any kind of limbs or anything that's attached to it, it will get dragged behind unless you want this to actually be opposed. For example, if the spaceship is attacking another spaceship, it can strike oppose. It's about to go attack. But I don't think that's what you're doing here. You know, I don't think you want to give it any kind of life or any kind of posing. This is more like a limb that's attached to it. So if this pendulum is swinging to the right, it will definitely be pulling. This spaceship is driving to the right, it will definitely be pulling. So you see, in that frame right here, you got to switch. You got to switch the arc to here. That's how that's why it's being pulled. All right, and then when it stops. It hits something, you got to be careful about these shapes. These shapes are not as pretty. You know, when you have the Z or S shape, you know, keep it always arced. You know, try not to get it to, unless your spaceship is gonna hit a wall, like probably here. When it hits a wall, bam, right there on that frame. When it hits, bam, right there. Let's say this frame, he's actually pulling it cleanly, and the next frame, right now when it hits, so that thing had a lot of energy in it, you know, when it was moving to the right. You know, let's take a look. Let's go back to the previous frame and we'll see. That's the amount of energy it's bringing. See that spacing right there? That's a lot of energy it's bringing. So at this point, that spacing, that amount of energy is carrying through this as well. That pendulum is carrying as much energy, right? So when this thing stops, when it hits, bam, right here, that next frame, it goes back for you, right? Because it bounces. But the pendulum does not know that. The pendulum has no idea that this just stopped. That pendulum will swing. It will go forward. And usually it could even do something shaped like this. And it probably would go straight. That thing, because it has weight to it, if this was a rope, you'll probably forget the rope. You'll probably forget the rope for the next couple poses. That when this hits, and this loses, and this still has forward momentum, it'll probably do an arc like this. And then it will hit here because the cable is pulling on it. Probably something like this. You see that? That's probably what's going to happen, because that thing is going to carry all that energy into it when this thing hits and bounces back. Because that cable in the middle is just a cable. It doesn't have any. It's the weight is all in that bob, in that arm, in that hand. So when it gets here, it'll probably drop down like this, dunk, because there's weight to it, and then it will bounce up probably because it's being dragged. It's being dragged by this cable. Then it'll get really messy, right? It'll just bob up and down as it's swinging as well a little bit. It gets really difficult at that point of how to do this to look right, and it's almost like dynamics, at that point. But hey, really, you have to understand that, right, to move forward with it. So when this hits, bam, it needs to bounce. It really needs to bounce back. Because right now, this thing has no weight anymore, especially that if let's say you didn't hit anything, and your spaceship is moving in this direction and you did not hit that wall right here, then your pendulum should be swinging this way when this is flying, in this direction. Does that make sense, David?
Yeah, yeah.
Yeah, perfect. So I think this one needs some work for you to really read. See, there it's good. Here it goes back to being good again. And even though I think it might be a little stiff in a couple places, like here maybe it's not as clean as your previous one. It's not bad though. It's really not bad. The last little bit is got some good stuff in it. It could just be a little cleaner. Especially shapes like this, you got to be careful about shapes like this. Maybe you could keep that going slightly longer so that it actually allows this to go all the way there, so you get a nicer arc, in it. This Z shape starts to really hurt the shape of the silhouette of the character. Yeah, some cool stuff in here though. All that stuff is nice at the end. It's really that first part. It's really that first part to try and really get the physics of that thing to work.